Okay, well, good morning and happy Monday. It's week 4, so it's like midterm season starting now, going to the rest of the quarter from now until Labor Day, or not Labor Day, Memorial Day. Okay, well, yes.
Could you publish the week 4 module?
Did I not publish?
I did not see it.
Oh man, okay. You are right. Okay, here it is. Module and publish the lecture view quiz. Okay, are we starting to Git as a publishing method for class content versus I don't know, downloading from BruinLearn manually? Okay, let's restart the kernel, clear all outputs. Okay, I'm going to now introduce NumPy. Okay, so this is a package or a package in Python that introduces a data structure called the array. Okay, so it's not part of base Python. You have to import it. Okay, so you call import NumPy just to kind of make your life easier, so you don't have to keep having to type out NumPy dot array or whatever you want to do every single time. We kind of shortcut this and we just do import NumPy as np, and then you can call just np dot array to create your arrays. Technically, you can do import NumPy as whatever other you want, whatever else you want to call it. But this is the convention, and you should follow it. It will make other people's life harder if you do not follow it. Okay, you can kind of just make sure NumPy is installed after you do import NumPy as np. Hopefully, it does not throw an error. And you can do np.double_version double_, and if it's not there, you'll get an error. Yeah, question.
So what if we do get an error?
If you don't have NumPy? Okay, so then what you'll want to do is you'll quit Jupyter, and then you'll open up, it'll probably kick you out back to the terminal shell, okay? And then you'll call conda install numpy, okay? Conda install numpy, and that should do it because you installed with Anaconda, okay? And then so once you do that, then start Jupyter back up, JupyterLab, and then it should be in there, okay? And if still no, then let me know. So conda, when you do conda install numpy, it might take a couple seconds. It'll say like figuring out the node dependencies and things like that. So conda is like a package manager and an environment manager and things like that. It's this versatile tool. And the thing is one of the problems with, not problems, but just one of the things that you have to be aware of in Python is you have all of these packages that depend upon other packages, and so if you update a package, that might break other packages. Okay, so so as time goes on, like the functionality changes, and what used to work, they might change it, so now there was an error and things like that, and so so that could happen. And so conda will, if you say, so there's this very common thing. It worked on my computer, but then when I tried to, or like it worked on my home computer, and then when I came to school, it doesn't work anymore. And that's probably because you have slightly different versions of packages installed on one machine versus another machine. And so if you set up this kind of like an environment or a virtual environment, or you use a Conda to create environments, one of the things that Conda will do is it will keep track of every single version of every little module that was used. And so there is a little bit of kind of space wasted because when you set up one project environment, it'll download all of the exact versions of software used. And then if you start up another project and you set up a different environment there, it will also download all of the exact versions of the software used in that module and keep that on file, so that at any given time you can kind of switch, whatever thing is. I don't know. It's kind of like if you had a baking recipe and you said, I need this exact brand of butter, okay? So your refrigerator, you go out and you buy that exact brand of butter for your baking recipe. Someone else has a different baking recipe, slightly similar, but it's also slightly different, and their recipe says, I need this exact brand of butter, okay? So now you have to buy the different brand of butter. And so now your fridge is getting full of like all of these different brands of butter, and that's just how it goes, okay? Luckily, you probably have like a terabyte of storage on your machine, and each of these things are just a few hundred kilobytes, so it's not a huge deal. But some are bigger, but usually it's not a problem. Okay. Anyway, NumPy working on everybody's machine now? Okay, great. Okay, so with NumPy, we have something called the array. And you can create arrays directly by calling numpy.array, and then inside that parentheses you put in like a list, and this will convert it into a NumPy array. And so it comes back and it says array with the values 1, 2, 3. Okay? Now, the key difference between an array and a list is that values in an array all have to be of the same data type. So kind of like a vector in R, okay? So vectors in R, all of the values have to be of the same data type, and arrays in NumPy, all the values have to be of the same data type, okay? Lists in Python, you can have different data types in a list. You can have numbers, you can have strings, and we saw that in like a bunch of the lists that we made last week. We had like, what was it, like family is like Liz 1.7 meters or whatever, something like that, right? Okay, so but in array, as they all have to be of the same data type, and they're mutable, so they can be modified in place and things like that. Okay, so here I'm going to create an array, values 1, 2, 3. I'm going to store it as A. When you print an array, when you call print on an array, you get out, this is the format that you will see. Square bracket 1, 2, 3, okay? What's the difference between 3 and 4? Cell block 3, where I did numpy.array. Is there a difference between the array in 3 and the array created in 4 that I've given the name A to? And the answer is no. They are, they're different objects, but as far as the content and what their data structure are, they are the same. They're both arrays. It's just sometimes Python will return the object itself, and when it returns the object itself, as number 3 does, it will print out array, parentheses, square bracket, 1, 2, 3. If you ask Python to print an array, you'll get, it'll come out looking like this, square bracket 1 space 2 space 3, okay? But, as far as content goes, that's how it goes. So when you, one thing to note is that when you print an array, there's no commas in between the values. When you print a list, there's going to be commas between the values. So here's the list of the integers 1, 2, 3. This is an integer array with the values 1, 2, 3 in there, okay? If you ask what is the type on an array, you get NumPy. NumPy.ndArray is the data structure, data type for an array. So I'm gonna, as I work through these things, sometimes I will produce the output, the array directly, and you'll see this array parentheses square bracket. Sometimes I will call print on the output, and you will just see the square brackets, okay? So just get used to seeing both, and just know that both of those are kind of, that they're arrays. Okay, so one thing you gotta keep in mind is that because arrays always have to have, all the values have to be of the same data type, arrays perform upcasting, which in R we call this coercion. So when you mix like a integer with a float in R, what are they called? Integers and doubles. Okay, in R's it'll convert the integers into doubles, no problem. In Python, the integers get converted into floats, so we call that, they're upcast into floats. So here I've got an array, and in going into the array I have the list with the value integer 1, integer 2, float 3, because I've got 3.0, and then boolean false, boolean true. It's going to upcast all of these into floats, and so here the false gets upcast into 0, true gets upcast into 1. The integers remain that, and this is Python's notation, or NumPy and Python's notation to let you know that everything is a float, is that it includes the little decimal point there. So you get 1 dot, 2 dot, 3 dot, and that decimal point lets you know that these are floats. Okay. I don't know, is Python localized in that, like, because in Europe they use comma as the what do you call the thing? Is it called the decimal point, or is it called a decimal comma? What do they call it in Europe? The decimal delineator between fractional values. But I don't know. Is Python localized, and does it appear as commas? Because that would be confusing to me. I imagine it's still dots, but this is like the advantage of being living in America, I guess. Okay, here I have a string, right? I've got a string here, so everything's gonna get upcast into strings, and that's what you get. Okay, you can have higher dimensional arrays. So these are just one-dimensional. They're kind of like vectors, but here you can create a two-dimensional array. So here I'm going to give it I'm going to create an array. And going into that, I've got a list, an outer list, and in that list I've got two lists of length 3. And so Python will see this, and we'll see, okay, I'm going to create a 2 by 3 array. So basically this is like a matrix. Okay, so I get 1, 2, 3 in the top, 4, 5, 6 in the second row, and this is basically a two-dimensional array, or we would call this a matrix. Okay, if you try to do something like this, okay, and the behavior of NumPy has changed. So if you have an older version of NumPy, this might not throw an error, but people said, you know, nobody ever does this intentionally in NumPy, and so now we wanted to throw an error. And so here I'm trying to create an error with, I got 1, 2, 3 on the top and 4, 5 for the second thing. You get a dimension mismatch. So here if I try to run this, I get an error, and it says setting an array element with a sequence, and the requested array has an inhomogeneous shape after one dimension. So I mean that's a pretty lengthy and descriptive error message, which we like. Okay, we like descriptive error messages that help us figure out what we did wrong. Okay, but anyway, that's how you can create some arrays kind of manually. Oh, all right. Let me give you your first VQuiz answer. Letter B. B as in bear. All right. These are probably some of the quickest ways you'll create arrays. So here you can just do NP zeros, give it a value, and so this will give you five zeros in here. And the default is it's going to be floating floats. If you want integers, you can call dtype data type integers, and you'll get integer zeros instead. You can also, as far as the argument that goes into np.zeros, you can give it a tuple, okay, or a list. Okay, you can give it a tuple value containing 2, 4, or list with 2, 4, and what that will do is it'll create a 2 by 4 matrix, or 2 by 4 array, I should say. Okay, 2 rows, 4 columns there. Okay, you can give it even like higher dimensional or longer tuples. So 2, 3, 4. This will create a 3-dimensional I'm having trouble talking. Okay, 3-dimensional array. Okay, so the last one is going to be the number of columns. The middle one is the number of rows, and 2 is the number of like layers. Okay, so you'll get 2, each of them being 3 by 4. And what about this? 2 by 3 by 4 by 5. This is a 4-dimensional data structure, and so kind of working backwards, columns, rows, then layers or sheets, then blocks. So now you have, it's kind of hard to see, but this is a 3-dimensional array, right? So you think of this 4 by 5 sheet stacked on top of this 4 by 5 sheet, stacked on top of this 4 by 5 sheet. So now you have this 3-dimensional block that's 3 by 4 by 5. And then in 4-dimensional space, you have this other dimension, or this other block that's 3 by 4 by 5, right? And so anyway, you have that. It's kind of hard to visualize, but basically 2 blocks, but these represent different layers within the 4th dimensional space, or hyperspace, or whatever. Okay. Anyway, so you have so these are np.zeros. You have the exact, basically the same function, but called ones. And instead of zeros, you get ones. Okay. So because as far as starting values go, those are probably the most common starting values you would use, either zeros or ones. As far as like, I need to create something with just an empty array full of values or something, okay? And then, but if for whatever reason you want to provide a different starting value, you can do that. You go np.full, and then just whatever, you put the dimensions in, and then you put in whatever value you want repeated. So here I'm going to get 1.2 in a 2 by 3 arrangement. Okay. Sometimes we want random numbers. NumPy. So there's also a random package in base Python, but NumPy also has a very good random assortment of things. So you can call numpy.random, numpy.random, and then 1 is you can set the seed, which is anytime you do random stuff on a computer, it is advised that you set a seed somewhere so that you can kind of reproduce your results later on. So here I'm going to do just numpy.random seed 1, and then you know, you just want random values on 0, 1. You call random.random. Okay, numpy.random.random, however many values you want. Here I'm going to ask for 5 values. And so I get 5 values, 4.1 times 10 to the negative, so that's what, 0.417, 0.72. This one's pretty small, 1.1 times 10 to the negative 4. I don't know. Okay, so anyway, those are your 5 random uniform values. That's that. Okay, you want random normal values, centered at 0, standard deviation 1. you can call random.randn, and that will give you 5. Here I'm going to get 5 values from the standard normal. Look at that. I get 1.1, 1.654, negative 2. Okay, so that's that. Oh, just curious. Well, I don't want to do it, but so that's random normal values. If you want, you can also get normal distribution values, and you specify your own mean and your own standard deviation. And here you can put in all of these things. So here I've just been putting in the number 5, and it gives me 5 of them. But you can always put in like a tuple, right? And you can say, I want 5 by 3, right? I want 50. Oh, didn't like that. Do I do this? No. Okay. Now I'm confused. Okay. I gotta read the help. Thought I could. Random n. Oh, I can't read this. Okay, return a sample from the standard normal distribution. This is a convenience function. New code should use the no. Oh, okay. Standard normal. Oh, random.generator. Okay, all right. I guess this is deprecated now. All right. And I haven't been reading the help function, so. And we also have random.generator, standard normal. Oh gosh. All right. Well, this still works. It's just I guess they don't like it anymore. Random normal. Random.generator.standard normal. Okay, that the new code should be this. All right. Well, we can also do that. Let's see. Oh, I called NP. Doesn't like this. Descriptor doesn't apply to an int. Oh, I gotta ask for help on this again. Okay, so size, standard underscore normal, size dtype, size none, int or tuple of ints. Why is this not working then? It's just random.standard normal 5. Okay, all right. And just random.standard normal, or you can give it a tuple 5, 2. All right, that's what I've been wanting to do. All right, so anyway, that's standard normal. You can do that. Okay, random.normal, you can specify your mean and standard deviation here. Location, scale, or mean and standard deviation, size, and all of these things. numpy.random.generator.normal method instead of a numpy.random.generator instance instead. Please see random quickstart. Okay, well, I'm a little bit confused by that help there. All right, well, anyway, these will all produce random values. Random ints will create random integer values. So here, 0, 10 will produce basically single-digit random values. It's this will produce 20 values, 0 up to 10 exclusive. So 0 through 9 basically will be your random values there. So if you wanted to simulate dice rolls, you would go from 1 to 7, because it would go 1 up to, but not including 7. I know it's a little bit confusing, but that's just, I guess, using the range kind of notation for these things. And more information on random generation, you can kind of find this on numpy.random in the help documentation there. random generators, default RNG. Okay, lots of examples there. Okay, sequences. You have range objects, okay, in Python, and we can turn those range objects and put them into lists. And so, you know, range 0, 10, 2 will give us 0, 2, 4, 6, 8. And similarly, you have numpy.arange. This will create an array based on a range. So here I can do numpy.arange, and this will create an array with the values 0, 2, 4, 6, 8. Okay? You could also take Python's base range function and throw that into numpy.array, and you'll get the exact same result. But numpy.arange is gonna be pretty great. So you can do 0, 10, 5, and so on and so forth. And if you just need like something of a certain length, starting at 0, counting up by 1, you can just call numpy.arange, and you just put in the integer 20, and it'll give you 0 through 19. And it's pretty great, okay? You also have .linspace. This will create linearly spaced values so that the beginning, the space in between increments will remain the same. So, so this, you have the start and the stop, okay? Now this is one thing to keep in mind, is that the stop is inclusive with the length of the numbers. So if you want the numbers 0 through 100 spaced out by 10, your length is 11, okay? So that feels a little odd, but this is, if you do 0 through 100, you need a length of 11, and it'll count out by tens, right? 0, 10, 20, 30, up through 100. If you did something like 0, 100, and they say length 10, now it will start at 0, end at 100, but because it's going to give you a total of 10, there's kind of just 9 things in between, and so it increments by 11.11. So it goes 0, 11.11, and so on and so forth. Now, you could do like 0, 110, endpoint equals false, right? And this will go from 0 through 90. So maybe that's what you wanted, okay? But it's a little hard to predict and calculate. I mean, it's not hard to predict, but it takes time to stop and think about it. Because if you do something like 0, 100, 9, saying I want a length of 9 and endpoint false, so I don't want to include 100, then the endpoint ends up being 88.88, okay? Which makes sense if you think about it, because basically it's doing the same thing as this, and it's just leaving off the endpoint. But if I just gave you this and I said, give me the endpoint, you'd have to like sit and think about it for a little while before you knew that the endpoint was going to be 88.88. Okay, it's not as clear as something like, you know, give me a range with step size 10 or something like that. Okay, I gave you one view quiz already. All right, your second view quiz answer is the letter A. A as in apple. Okay. So here I'm going to create a 3x4 array with of ones. Okay. So this is 3x4, and you have a few things. Okay. ndim is how many dimensions this is. So it's 2-dimensional. Okay. So ndim is going to be 2. All right. So these are just attributes. So x is my NumPy array, and you can do x dot, and you get any of the attributes to get these things out. So whatever your array is, you do x dot ndim, you get 2. The shape is 3x4. So that's what you have. Okay, what kind of values are in x? They're floats. 64-bit floats to be precise. and if you wanted to, you could have, I think, 32-bit floats and 80-bit floats. I think those are options as well. Okay, here I'm going to create a range, 0, 12, 1, what's that going to go? That's going to go from 0 to 11, right? So that's what we have. How many dimensions is this? This is one dimensional, okay? So it's just a one-dimensional array. It looks, I keep wanting to call this a vector, but it's a one-dimensional NumPy array. So you ask for y.ndim. It's one-dimensional. All right, what do you think the shape of this is? If I ask, what is the shape of this one-dimensional array, what we're going to get back is we're going to get a tuple with the value 12 and nothing else. Okay? Because it's not 1 by 12. It is just length 12. So it's that's important to keep in mind. Okay. All right. So we have a couple tools that we can use to reshape our arrays. One of the simplest is .t, and this is going to transpose an array. Okay, or at least return a transposed version of the array. You also have .reshape, and you take your currently existing array and then you provide it as an argument, basically a tuple or a list giving the new shape. Okay. You can also call array.reshape. Arrays have reshape methods where you provide it the shape. Okay, so here J is one-dimensional, K is two-dimensional, K is 3 by 4. Both have 12 things. Okay. I'm sorry. So what I did here, I took J and I reshaped it into a 3 by 4. Sorry. Okay. So K is taking J, which is length 12, one-dimensional. I reshaped it into a 3 by 4. J itself is unchanged. J is still this one-dimensional length 12 array. You can also call J.reshape. J.reshape is going to return a, here I said J.reshape 4 by 3. So that's going to return a 4 by 3 matrix. Okay. But again, in NumPy, contrast this to say like lists in base Python. These methods, their default behavior is to return a new object rather than modify the object in place. Okay, so J is left unchanged as well. Also notice when it reshapes, in Python, it reshapes it row-wise, okay, versus in R, if you have a one-dimensional vector and you gave it dimensions, it generally reshapes it column-wise, okay? So that's, but notice in Python, it reshapes it row-wise, 0, 1, 2, 3 across the row. Okay, here K is my 3 by 4. I can ask, what is the transpose of K? And we get exactly what we expect, right? Now I get a 4 by 3, and 0, 1, 2, 3 goes down the column here, okay? And again, calling K.T, getting the transpose of K does not modify K. K is still going to be 3 by 4. All of these things return arrays themselves, so you can chain these methods. You can do dot chaining of methods. So I can start off with an A range, 0, 12, comma 1. Then I can reshape it into a 3 by 4, and then I can call .t to transpose it, right? And so what am I going to get? I'm going to get the shape is going to be what? 4 by 3, and then down the column it will go 0, 1, 2, 3. Next column, 4, 5, 6, 7, like that. Okay. Sometimes when you see things in NumPy, you'll see a -1. Okay, and you're just like, what is a -1? Okay, -1 is I can't be bothered to do the math, so Python, please figure this out. Okay, so here J is length 12, right? And you say I want to reshape this so I have 3 rows in it. Okay, so you can do J.reshape 3. Now 12 is simple enough where I can say, okay, the result is going to be 3 by 4. Okay, but what if you had a really big thing and you didn't want to have to do the division to figure out exactly how many rows or columns or something. And especially if you're in a higher dimensional thing, you know, trying to figure out exactly how many, I don't know, layers or whatever you need could get tedious. So you can put in a -1 here, and basically you're telling Python, I want 3 rows, and Python, you do the math to figure out how many columns I need, okay? And it figures it out, and it says, okay, in order to get this to work, we need 4 columns, okay? Similarly, I can do j.reshape, j is length 12. I can say, I don't know how many rows I want, but I do know I want 4 columns, okay? And so you can put in the -1. So that's what it means to see a -1 in a, whatever you call this, in NumPy, whenever you see dimensions, something in there, okay? Okay, so you can have, you can also do it for like a 3 thing, and you can say, I want 2 layers, an unknown number of rows, and 2 columns, and it will figure that out, okay? So it says, okay, you got 2, and now you need a 3 and 2, and so on and so forth. Okay, so okay, here again, y is a length 12 one-dimensional array. Length 12 one-dimensional array. The shape is just a tuple with the value 12 in it. It's one-dimensional. So here's a question. What happens if I call transpose on y? So there's no other dimension to swap. So the transpose of a one-dimensional thing is still just a one-dimensional thing, okay? Which is, this behavior is different from R, because if you give R a vector and you call transpose on it, R is going to like make a matrix out of it and make a column, okay? Python NumPy just says, hey, this is one-dimensional. You can't transpose a one-dimensional object. It's still one-dimensional. So that's not going to work, okay? If you ask, hey, what's the shape on this transpose thing, y.t.shape, it's just 12, okay? Now, if I take y and I reshape it into 1/12, okay? And so this is a subtle difference, right? Look at how y gets printed out, and look how z gets printed out. They look almost exactly the same. The only difference, the clue that this is now 2-dimensional, is that the square brackets that open up z, there's 2 of them, okay? So when you see 2 opening square brackets, that indicates that it's 2-dimensional. So the number of opening square brackets is an indicator of how many dimensions you have. So here you got 2 opening square brackets, that's going to be 2-dimensional. And then where did I go? All the way back here. I have 1, 2, 3, 4 opening square brackets. Here I got 3 opening square brackets to indicate it's 3-dimensional. Okay. So anyway, this is kind of the only clue that we have is how many opening square brackets we have. And so this is like one of those things, like, this is just how coding works, is that there are usually some hints in the output to let you know what's happening. And so this is a little bit of a subtle thing, 2 opening square brackets. And so, you know, I don't have this handwritten code business stuff, but it's like, this would be something you want to pay attention to. Okay, so if I ask, what is the shape of z? What is the shape of z? Well, you see it right here. It's going to be 1/12, right? Because I said reshape y into 1/12. So z is going to be 1/12. So I get this tuple 1/12. And now when I say transpose z, it's going to swap those dimensions and we'll get a 12/1. Okay? And so there I get the column, and that's what it looks like. z.transpose.shape, 12/1. Okay? So I think this is one thing that our users get accustomed to. And then this is also one thing that Python users complain about R. They say, well, you shouldn't, when you transpose, like, transposing a vector shouldn't do, result in this or something, right? It's a little bit of a different philosophy and stuff, but you have that. Okay, you can slice and subset arrays. So this kind of the same kind of rules apply for subsetting slicing lists. So here, what is square bracket 4 gives you the index 4 thing. And here, the shape is, it's one-dimensional, length 12. So you can also just slice from index 4 to 6, okay? And that will just give you the array containing 4 and 5. Okay, so same kind of slicing rules that applied to lists. So 4:6 will give you just the values 4 and 5. You can also put in a second colon. So you can say 1:8:3. That's going to be start at 1, go up to, but not including 8, step size of 3. So that will give us 1, 4, and 7. You can give no starting point, ending at 100, go step size 2. So if I do a range 100, that will be 0 through 99, and this will give us all of the even numbers from 0 to 98. You can also just create if you knew that you wanted to do something like this, you can call a range, and this is just like a range object, has a step size. You can also do that as well. Okay, here is a Z. Z is a 3x4 matrix. I reshaped my 12 values into a 3x4 matrix. What you can do is you can also subset, now that you have a two-dimensional thing, when you subset with square brackets here, you can give it, so you can specify which row and which column. So here I want row index 1, that's the middle row, and column index 2, that's the third column. So this is going to give me the value 6. Okay, when you subset down to a single value, then the data type, you just get the value itself. Okay, so this is a 32-bit NumPy integer. Here, I can subset 0:2, 0:2. This gives me basically this top left 2x2, right? So I want slicing from 0 to 2. It's going to give me 0, 1, 4, 5 when I slice that. Okay, 0, 1, 4, 5. And if you slice, you can do 2 comma and then blank colon. This will give you row index 2, all of the columns. Okay. In fact, I'm pretty sure if I don't specify anything here, so unlike R, I think this will come. Oh no. I guess no problem there. I thought it was going to give me a complaint about it. Okay, and then when you ask what is the shape of this, it's one-dimensional. Same kind of thing, colon, comma 2 will give you the column at 2. And then again, the shape there is also one-dimensional there. All right, so this is kind of neat. Slices are view objects, okay? So here is Z. Here I'm going to subset. I just want the first 2 rows and the first 2 columns. I'm going to call this object Z underscore sub. Z underscore sub. Okay. So this subset thing, when I slice this is what we call a view object, meaning it is tied to this matrix or to this array here. And so arrays are mutable. So I can say I want to modify this value in the top left corner from 0 to 99. Okay, so I do that there. When I say, hey, show me this window, this is a view, I want to just look at this top left corner here. Okay, notice I only modified Z, I didn't modify Z sub, but because Z sub is pointing to Z, that top left value gets updated to 99. Okay, and Z, you can see the full array, that top left value is also 99. So both of these things are still pointing to that thing. Z sub is just a view object of that. Okay. Here, I'm going to define an entire new array, and I'm going to give it the name Z. Okay? So Z now has 0 through 14 in this array. Okay? Z sub is still pointing at this top left window, 2x2 window, into whatever array this is. Now this full array doesn't have a name. Okay, so I can't really get at it. Okay, but Z sub does have that there. Okay. If you want to copy, that's not going to do that. You can do array.copy. So here's Z 1 through 14. You can do, I want to just look at this top left corner 0, 1, 5, 6, but I want a copy of it. So you call .copy on that. And so now you get 0, 1, 5, 6. You can modify that top left corner, and the copy is unmodified even though we did change that top left corner to 55. Okay, and I think that makes sense. Okay, here's a new array. We're going to just look at, again, top left corner here. Top left corner is now 99. Z is also 99. You can say, hey, what is the type of this thing? Okay, the view objects themselves are arrays, and so they contain kind of all of the same methods and attributes. So this view object, which is this top left corner, 99145, I can reshape it. Okay, and if I reshaped it, it doesn't affect this. I think I can also do, I can change this. Okay, and what was the original array called? Z is going to get modified too. So you can, if you modify the view object, it's going to modify the underlying array as well. Okay, that will be it as far as our introduction to NumPy. Again, just working with this new data structure, the NumPy array, which has a lot of similar features similar to, say, vectors and matrices in R, but also just things that are a little bit different just because R is a tiny bit of a quirky language. So there's a few things that you might have gotten used to doing in R that just aren't going to work or cut it or fly in Python either. Okay, so we'll wrap it up there, and I'll give you your third view quiz answer.